All right, welcome back. This is Unit 8 for AP Environmental Science, Aquatic and Terrestrial Pollution. This is our 15th section, our 14th video. This is the final video for the unit, all about pathogens and infectious diseases. The 5-second rule. Don't forget, if you drop food on the ground, bacteria and different pathogens have to wait 5 seconds. It's a rule. So, pathogens adapt to take advantage of new opportunities to infect and spread through human populations. If you've ever played the game Pandemic, you create a pathogen and you try to give it different types of mutations and attributes to try and wipe out the entire world population by spreading it. And so it's a fun game if you ever get a chance, but the reason it's a fun game is because it is fairly realistic as far as looking at, how could a pathogen spread and affect the most people. Now, there are certain pathogens that can occur in many environments regardless of the sanitary conditions. This is a map of the coronavirus, for example, which we are obviously seeing our current pandemic going on. Now, climate change actually increases the pathogens and the associated diseases spreading to new areas. There is a relationship between climate change and infectious diseases increasing. So here's an example here. As warming increases, the tolerance range of those pathogens increases because they can survive in higher temperatures. So certain pathogens that are better apt in higher temperatures will do better. Climate warming can actually accelerate the transmission cycle. So in a normal transmission cycle, we have low transmission during the colder month or during the summer, and then in 1 year, and then it increases. So we have an every other year kind of spread. Whereas now climate warming is actually causing for every year where we see these increases in pathogens. Now, as climate warming exceeds the upper thermal tolerances of pathogens, you're going to see more pathogens existing more often. So regional variations in climate change, we can see here, versus the increasing and earlier impacts of climate. So as we have more warming and climate variability, epidemics and reemergence of epidemic diseases occurs because they're able to just move with the change in climate. As we have warming in North America, poleward, it will actually spread VBD and zoonoses. And then warming in Canada, for example, introduces exotic vectors and pathogens, so new ways of pathogens spreading with warming. Now, places that are poverty-stricken often have less sanitary waste disposal and have contaminated drinking water, which causes them to be more susceptible for pathogens to spread. This is why typically you see big outbreaks starting in lower socioeconomic areas as opposed to higher developed countries. There's a much higher likelihood for the spread of infectious diseases because, for one reason, wastewater carries a wide variety of pathogens. So we have cellular pathogens like parasites, protozoa, which causes malaria, fungi, and prokaryotes, which can cause leprosy. And then there are acellular, which are non-living pathogens like viruses and prions. Hopefully, if you had a chance to take microbiology, you probably learned about all of these. So we'll look at some of the different pathogens in the past, and we're gonna, depending on time, you might have a chance to investigate some of these yourself. But there are videos, if you want to watch videos on these. I think we might watch those in class. It really depends on time. That's always going to be a huge part of it. But the plague was a bacterial pathogen that infected organism. An infected organism would bite a human or have contact with contaminated fluids or tissues, which would then spread to the humans. Tuberculosis is also bacterial. Basically, it spread through the bacteria from bodily fluids of an infected person. So droplets like from coughs or sneezes can help spread tuberculosis. Malaria is a protist, where an infected organism bites humans or has contact with contaminated fluids or tissues. Mosquitoes are the big transmitter of the malaria protist. The West Nile virus, you may have remembered hearing about, but an infected organism bites the human or has contact with contaminated fluids or tissues. The West Nile virus actually had an infected mosquito can transmit to the bird or the other way around, and then those mosquitoes would spread West Nile to animals, humans, and other animals. SARS was an infected organism that bites humans or has contact with contaminated fluids or tissues. So you get an idea that this is pretty much how most of these diseases have spread into humans. But there was a SARS epidemic in 2002 and 2003 where it started in China, and those cases actually spread. Now this was considered to be a better, better response because it didn't get as widespread as it could have been. But like in the United States, there were 29 people affected. No one died in the United States. It wasn't a huge pandemic because it didn't actually get everywhere. MERS is another one which was the Middle East respiratory syndrome, where it was transferred from animals to humans. This was a virus. We look at coronavirus. It's COVID-19. MERS and SARS are very similar, where this disease can actually spread from animals into humans, and then humans then communicate it to other humans. So MERS, CoV, and animals have exposure and transmission. You can kind of get an idea of how those different animals spread to other animals or other humans. And then for the most part, close contact was how it was spread to other humans. The Zika virus came from mosquitoes and sexual contact. This was a pretty big scare not but a few years ago. So they were saying anyone going to Zika-affected areas should try to avoid mosquito bites because that is the best way to avoid the exposure. The Zika virus was the biggest problem was in mothers that were pregnant because it could spread to the baby and cause the baby to have birth deformalities. Cholera is another one that's bacteria. This comes from infected water. Essentially, there's easy ways to prevent cholera spreading from areas. If you're found in an area with cholera, you want to drink bottled water or water that has been treated. You should always thoroughly cook your food. You should thoroughly clean fruits or just get your own, peel your own foods and fruits. You want to be wary of ice and raw foods or ice cream and street food because you don't know if it's been treated. And you always want to wash your hands frequently. Remember, 1 billion people do not have sufficient access to safe water. So about 40% of the world's population lacks access to proper sanitation and hygiene. And in sub-Saharan Africa, it's up to 64% that lack access. It's important to understand that just because we have access to clean water doesn't mean everyone does. So this is a great graph to show you the population that uses improved sanitation in percentage. So you can see in developed countries there are there's better sanitation, better treatment, so there are less cases of those diseases spreading in water. But then, of course, sub-Saharan Africa, Asia, and slightly higher in South America and in Latin America. Now, an indicator species, just a reminder, in case you forgot what indicator species are, an indicator species can actually help us to find out if pathogens are present or not. So, for instance, fecal chloroform bacteria like E. coli can actually tell us that human waste has entered the water. So it's important. We can actually test for E. coli to find out if there is waste in the water, and that is something that we do. That's why they test for it. That's why you've seen, oh, hey, we don't have any romaine lettuce because we found fecal coliforms and E. coli in the water that was being tested. That is the end of our final video for Unit 8, aquatic and terrestrial pollution. If you have any questions, please ask. Email me, text me, or ask in class.